In today's sessions, we'll continue with the same tours we started in part one. What did we got in part one? We learned how to create a cube out of a raw data we got in the PTO database. We created 4 dimensions and effect table. We made sure that the effect tables will have all the numbers in it, and we made sure that every dimensional table will have a key, which is an integer. And then we hooked up the whole things, and now we already have a nice mini cube that we had. And we learned some of the SQL command. Okay, what are we going to do today? And start to them, of course. In part two, we also get some raw data. In a minute, I will describe it. And we want to end up with a table that report the reporting of employees of their hours, some of which are billable, some of which are not billable, and the rate for each hour, and et cetera, et cetera. We dive into the information inside the table. That's going to be like our fact table. Then we're going to create also a dim date, which will have us, will give us a dimension that keep track of the dates. And the date it's a little more involved, which will include which month of the year it is, which week of the year, and which year it is, which day of the week. And we might want to do analysis based on that information. Also, we'll have, since the billable hours or whatever employee is billing and entering the data in the fact table, we will have a dimensions called people. People really refer here to the employees that filling up the reporting their hours. So we would like to have information of type of people there, et cetera, their title and whatever. So we would like to end up with a table that will follow the rules we kind of used in order to create this table. I'll give one example. I would like to introduce first the raw data, and then I will show the SQLs we use to convert it to the right way. What do I mean by that? Let's open the SQL for a second. This is the raw data. I'm in a PTO database, and I'm going to use the PTO underscore DW underscore Amos for the process data. And here I will have the right tables to create the cube. Let's see the raw data. What do we have in the raw data? In fact, this is made of 3 reporting tables, which I appended. The first column tells me which tables I got the data from. So there was a table for January, there's a table for February and March. I can get rid of this column. I'm keeping it just for tracking purposes, but basically can be removed because I always can get this data from the column of the date. Here I see January 2019. Okay, 14th of January 2019, I can pull the month out of the date. I keep it just for convenience. Second, I have the employee ID. Employee ID, well, that could work, but it would be very slow. So we would like to maybe convert this one into an integer, and integer will make this table to work very fast. And in a second, we'll see how many rows we have. In fact, you can just remove the first top 1,000. When you run it, you will see in the bottom how many rows you have in this table. I'm not going to do it now, we'll do it later on. Basically, I look at all the other data. I have hours reported, hours cost, hour rate. Task ID tells me which kind of a task was done by the employee. And now other 2 tables that come with the raw data. The hours, and the hours is the one that we're just looking at now. We have the people. It's really the information about the employee. And the task is which types of tasks they can do. This task, if we look at this table for a second, we say it's a really small table. It tells me kind of an index of which kind of a task the person has done. This is giving me which categories it belongs to. For example, task 1001 TM, it's a billable hours. So it's a category of billable. And we're seeing that later on that this billable has a meaning of when we create type of reports, how many hours we build every month, and so on and so on, it becomes to be important. One thinks it could be a good idea. It's to get rid of this table altogether. What do I mean by that? I mean that I can go back to the hours. I do have a column here says task ID. Maybe I can combine those two tables, and after I combine the two tables, I will keep the columns that call category. I can do it right now, but I can do it a little clever way. It's in the last page, and I will explain that when we get to there. But keep in mind, we would like the information about the kind of task the employee does. So when an employee is reporting every row here, it's really reported by an employee, okay? For example, all of those run by the same employee. I see the ID is the same. This is a different employee, okay? Which kind of a task they have done, I will look at the column of the task. What the category it belongs to, the category belongs to, I can look it up here, but that's inconvenient, and I'm definitely not going to work that way. So what I'm going to do later on, it's combine table tasks with the hours. So I will have another column, let's say next to the task ID, will tell me which category it is, and then I can get rid of the table task. But it would be wise to do it later on in another stage to combine those two. The other one is the people. People means employees. So here we go. We have a table of the employees. We look at that again. ID, this is not the way we would like the ID, okay? So we will add to this table, or the table that we're gonna create that's gonna mimic this data, is to add another primary key, which will be a whole number. And that primary key will be hooked up to the hours table. And again, in order to be able to do that, we'll use the same trick we used in the previous session, converting this one into an integer as well, and then we'll be able to combine those two tables, or link, more correctly to say, link those two tables using a primary key, which is a whole number. So our task is stage number one. Let's turn this table to have a primary key. The rest of the information doesn't bother me for as of now. The date, maybe we can hook it up to a date dimension, but let's leave it for later on. For now, task number one is let's add a primary key to this table, or let's create another table and move this data into the new table, but the new table will have a primary key, which is a whole number. After we'll do that, we'll create another table. Let's look it up again in our presentation. This is the raw data we have, as I mentioned, hours, people, task. And we want to get to this kind of a structure. This is what we did last time. This one we want to do this time. We're going to have the hours linked to the people. And in the people, as you see here, we do have a primary key. That's what I would like to get to. And in the hours, I want to hook it up, people to the facts, using the primary key here and converting, so I will have a primary key of people. So I'm going to add another column here in the hours, and this one will be a whole integer, and that integer will be linked to the primary key here. Another things we're going to do, we do not have a table here for dates. And we would like to do it in the right way. Doing it in the right way means let's create another table from scratch in the database, and that table will be designed for dates. We'll do it more general. It's really a good exercise. How will you build a dim date? And you put some parameters, and you can populate this table for dates that you want. For example, I might interested to do dates from the beginning of 2001 up to today. I would like to put this as a parameter and let's have the code in SQL kind of populate the data from 2001 up to today. So I don't really have to do it, definitely not manually. So summing up what we're going to do, we're going to add another primary key to this table. We're going to link it to fact hours, and then we're also going to create a date table, combine it to the fact hours, and as we do that, as we're combining those two and linking them, we also, in the middle, will put also the tasks, as I mentioned before. Instead of having here a task and combine it to a table, instead of keeping this table by itself and linking it, we just, since we only need the category, we just kind of add a category to this table and get rid of the tasks table. So let's go and start doing it. All the SQLs are in the website, and you have a link for Moody's to these tables. I'm adding all the SQLs into here, so you can, every SQL I use, you can download it from here. It might be instructive to start with the people one. It's straightforward, it's relatively easy, and a lot of the tools we acquired in SQL in the previous sessions, we kind of use them and get some experience of how to do those kind of exercises. So here we go. I have a very simple table. All what I want is a primary key. So I'm going to create a new table. Let's look at here. And this one, let's go into, here we go. And not this one, not this one. Here we go. Okay, this file, which you can download from the website, which I provided to you, it's creating a table. We're already familiar how to create a table. This part we already mentioned previously, okay? You can really ignore those ones, just default in creating a table. This one just telling me whatever I'm going to do, it's going to be in the database called PTO_DW_Amos. In your case, when you do this exercise as an assignment, you just change Amos to your team name, and then everything's going to your database. Here is the actual creations of the table. Start looking familiar. As I mentioned, all you really care is the name of the table you're going to create. I'm going to call it DimPeople. In the middle, we have all the columns we're going to use. And if you see, all the columns are almost the same as in the original tables: ID, name, title, etc. And all the column I added is the P key. This is going to be the primary key for the DimPeople. This is also supposed to be already familiar by now. I added the identity, meaning I'm not going to populate this column. It's going to be populated automatically by the database. So in other words, after I create this table, I'm going to move all the data from the from the people table into this table, and the primary key will be created automatically. One more thing to remind you, we would like to make this one as a primary key, and this is the definition for the primary key. As I mentioned before, I'm not going to dive what the meaning of everything is. The only things you really need to do is, this one is creating the primary key, and all what you have to do is to have here a special name, not a special name, but a name that reflects the primary key for this specific table. You can't really have the same primary key in two different tables having the same name. So if each table has to have its own primary key, have its own name for that primary key. In the actual life, you really would never use that. Most likely you never use that name unless you do something very complex. This one designed to say that this column going to be the primary key. Okay, we have done that in the previous session. This is another example. Okay, so stage number one, we're going to create a table called DimPeople. But let me make sure I didn't create it already. So if I created it, I would like your help or try to think about how will I delete this table before I recreate it. So do I have DimPeople? Yeah, I do have DimPeople. If I will run this one, I will get an error because it will tell me you already have one. So, and let's we know that the drop command will delete the table, and then I will recreate it. Let's say I forgot that command, okay? You have a really nice feature here that you don't really have to remember exactly what the drop command look like. You can do right click, and here you have something nice called script table as, and you can just go into the drop and it will create a drop command for you. So if you forgot the command, in fact, this one is simple to remember, but it's good to know that it exists. In fact, all I really need, it's this command. This one will drop the table. Very simple command. Drop table and the name of the table. I'm going to copy it and I'm deleting it. I don't really need it here. I will just put it here. So what's going to happen now, the goal means do it right now. Don't continue. Before you continue, just do that first. If I didn't put the goal, it will continue and it will do it sequence. I would like it to, I usually try to put the goal, then I know that this one is done. And after this one is done, it is going to create the table. Most of the time, if you leave out the goal, nothing will happen and after things will work fine. But it's a good practice to keep it there. Okay, so let's run this one. I'm running just this one by itself. This one, in fact, deleting. Oh, it tells me I cannot delete this one because it's referenced by a foreign key to another one. Wow. So what should I do now? It doesn't delete it because there is already, when I created all those tables, in fact, I link them as well. And when I link them, there is a contact between them. And if there is a contact between them, it doesn't allow me to delete it. So what should I do? I have to delete it in the right order. I have to delete the ones that they are dependent on each other. If we look at our schema here, we see that the people is linked to the hours. And in fact, if I would try to delete people, it won't let me because it's linked to the fact, okay? So let's try, maybe we'll delete the fact hours first and then see what happens if we can delete also the same one. How do we do that? We can copy the same one and just change it to fact hours. So let's delete first the fact hours. And let's see if it works now. Let's run those two. Yeah, that works. Okay, makes sense. People link to hours. So people really depends on hours. You can't really delete people before you delete hours. There's another table I would like to delete, and we'll recreate it again. I already have done it. It's called dim date. So let me add it here as well. And let me run the last one. So we know I deleted everything I have done before. Okay, this one also deleted. If we refresh the tables, we'll see that those 3 tables are gone. The reason I had to do that is just because I prepared it before I start recording to make sure that everything works right. And indeed, all those tables are gone. Okay, after we have and we make sure those tables are deleted, we can create now, and the creation should be just fine. Let's see, let's do it. By the way, if you notice, I can mark the code that I want to run. This code is just creating an empty table. Now I have an empty DimPeople. If I will refresh the tables, I will see that there is indeed an empty table called DimPeople. My next stage, here we go, we have DimPeople. This one is empty because I haven't put any data. What do we have here? This one should look a little familiar. The first things that your attention should be into the select part. What am I selecting here? I'm selecting all the columns from the people table that is in the database PTO. PTO, as we mentioned in the previous sessions, hold all the raw data. So I have a table called people, and this one we just saw before. I'm going to take all the data from this one, and I'm going to insert it into a new table we just created. We just created these DimPeople. This is the code we just ran a second ago, DimPeople. But on which database it is? It is on PTO DW Amos. So we're transferring the data from the table people, which is in the PTO database. We're taking all the columns and we're going to insert them into a table called DimPeople, which is in the PTO underscore DW underscore Amos. And as we're inserting the data, okay, please notice I'm just repeating all the columns that they are in the DimPeople. Let's look at it again. If you notice, okay, this is all the columns that I have in this beside one. Why I'm not putting this one? Because this one is going to be populated automatically. In other words, I'm selecting all the columns from the people table, inserting them into DimPeople, but I'm not adding the column of the primary key because this one is going to be populated automatically. Let's run it and see what happens. Okay, there are 2,839 rows. Okay, let's open this table and see what does it have. If we open now the DimPeople, and look at it, in fact, it's exactly the same data. The only things I added is I added another column, which is an integer. And the reason I do that, just as I mentioned before so many times, to make this table to work very fast in a queue. Okay, I kept the previous ID just for references. So if there's somebody really wants to know what was the original index that they have put there originally, it's right there. It doesn't really affect any performance because really affect performance, it's the primary key. So I can really leave that one here just for references. I have the name of the person, title, employee type, etc. Okay, so I'm done basically preparing the people table, the people dimension, I should say, from the table. So I can close this one. And let's look again at our schema. In fact, we just generated these dim people. In the next recording, I'm going to talk about the dim date. Thank you.